Hello everyone, this is Rome from CanHub and welcome to another anatomy tutorial where this time we're going to be talking about the cerebellum. So what we're going to be doing is exploring mainly these two images that you see now on the screen. So on the top image we're looking at the caudal view of the cerebellum, while on the bottom image you can see then the cranial view of the cerebellum. So there is a lot to learn about this very beautiful and exciting structure of your brain, the cerebellum. If we move to the next image, you can see now the cerebellum highlighted in green, but now on a mid-sagittal section. The term cerebellum comes from Latin, which means a small brain. And if you see the cerebellum in this medial view of the brain, you see that it looks like a small brain that is located inferior to the occipital lobe of the brain, behind the brain stem. So the brain stem is here, as you can see. Now, inside the skull, the cerebellum is located in what we call the cerebellar fossa, which is highlighted here in green on this image of the superior view of the cranial vault, or the cranial base. The cerebellum plays a lot of functions, very important functions that we're going to talk about, but mainly it plays an important role in motor control. This structure does not initiate movement, but rather modifies the motor commands of the descending pathways to make movements more adaptive and accurate. The cerebellum receives input from the sensory system of the spinal cord and other parts of the brain, then integrating these to fine-tune motor activity. I would like to also add here that the cerebellum is involved in maintenance of balance and posture. And other functions associated to the cerebellum include coordination of voluntary movements, motor learning, and cognitive functions, for example, in language. Now, the cerebellum is a highly interconnected structure of the nervous system and has numerous connections with other parts of the nervous system. Now, all these afferent and afferent connections of the cerebellum come through three pairs of fiber systems, which then connect the cerebellum with the CNS, the central nervous system, and they are called peduncles, and we're going to be talking about them now. So there are three peduncles of the cerebellum that you need to know: the inferior peduncle, the middle peduncle, and finally the superior one. So on the following slides, we're going to be looking at these three pairs of structures. Starting with the very first one here on the list, now highlighted on this image where you see here also the brain stem. Notice here the brain stem, and you can also see here the thalamus. This is a posterior view of the brain stem, where you can also see here a bit of the cerebellum cut. Now, this structure highlighted is known as the inferior cerebellar peduncle, and let's start with this one, which sometimes is named as the restiform bodies. Now, they are thick, rope-like strands which are formed by fibers of the posterior spinocerebellar tract and the axons of the inferior olivarial nucleus, and they lie between the lower part of the fourth ventricle and the roots of the glossopharyngeal and vagus nerves. Another important point I would like to add here is that the inferior cerebellar peduncle, now that you see here on this image, still highlighting the structure, now these are connected to the spinal cord and the medulla oblongata with the cerebellum. And as we saw previously, they contain mainly afferent fibers, so fibers that arrive at the cerebellum from other regions of the nervous system, among which the most important is the spinocerebellar tract. Now we're going to be highlighting another one that we had on the list. These are known as the middle cerebellar peduncles. They're also called brachii pontes, which are by far the largest peduncles, and they contain only afferent fibers, so only fibers that arrive at the cerebellum. Another point I would like to add here, and now I'm moving here to this image of the caudal view of the cerebellum. You see now the middle cerebellar peduncles highlighted from this view. Now, to say that the fibers of these peduncles come from the pontine nuclei of the opposite side. So the middle cerebellar peduncles connect the cerebellum with the pons. This is the most important afferent connection of the cerebellum because the pontine nuclei receive input from the cerebral cortex, and finally the stimuli arrive via the middle cerebellar peduncles in the cortex of the cerebellar hemispheres. Now, these fibers that arrive at the cerebellum from the pathway are part of the so-called mossy fiber system. So you see that through the middle cerebellar peduncles, the cerebral cortex communicates with the cerebellum. And the way it does so is the cerebral cortex connects with then the pontine nuclei all the way to then the hemispheres of the cerebellum. Just here a list so you can remember and add to your notes. Now let's move on and talk about another set of peduncles. Now back to this image here. These are the superior cerebellar peduncles. They're also known as the brachii conjunctiva. Now these are the major efferent fibers of the cerebellum, meaning that these fibers exit from the cerebellum. So they emerge from the upper medial part of the white matter of the cerebellum, as you can see here on this illustration. And then they form the upper and lateral boundaries of the fourth ventricle. We're going to move on and still talk about the superior cerebellar peduncles, but now showing this image here. And as I said previously, the superior cerebellar peduncles carry most of the cerebellar efferent fibers, and they connect the cerebellar nuclei, mainly the dentate nucleus of the cerebellum, with the midbrain structures and the thalamus. So now that we have looked at all three pairs of the cerebellar peduncles in detail, let's just have a quick overview of these peduncles and their connections. Hopefully this will help you remember them more easily and commit to memorizing them. Now, the superior cerebellar peduncles transfer information from the cerebellum to the midbrain and the thalamus, while the middle cerebellar peduncles will be transferring information from the pons to the cerebellum, and the inferior cerebellar peduncles transfer information from the spinal cord and the medulla oblongata to the cerebellum. And now that we have covered the major connections of the cerebellum with the nervous system, now we're going to move and describe the different parts and lobes of the cerebellum. The cerebellum consists of two laterally large hemispheres which are united in the midline with this structure that you see here highlighted, the vermis. The name vermis comes from the Latin word worm, and as you can see in this illustration, the vermis resembles a worm or is worm-like, hence then the name. The surface of both hemispheres and the vermis is divided by numerous transverse fibers, giving it a laminated appearance. But I'd like to talk about and list the cerebellar fissures before we talk about them in a bit more detail. But these include the horizontal fissure, the primary fissure, and the retrotonsillar fissure. Let's start with the very first one here on the list, and now highlighting here on this image. Now this is the horizontal fissure of the cerebellum. This is the largest and deepest fissure in the cerebellum, and it commences or starts in front of the pons and extends around the dorsolateral border of each cerebellar hemisphere. Now this one divides the cerebellum into a superior and inferior surface. You can also see here the horizontal fissure of the cerebellum from the caudal view of the cerebellum. The next one we have on the list is this one that you see now highlighted, which is known as the primary fissure of the cerebellum. Now, the primary fissure of the cerebellum is a deep V-shaped fissure that marks the upper surface of this structure and divides the cerebellum into then the anterior lobe, which I can show you here in highlight, and also divides it into the posterior lobe, as you can see also here highlighted in green. Finally, on our list, we're going to be seeing this fissure here, which is known as the retrotonsillar fissure of the cerebellum. This is a curving fissure on the inferior surface of the cerebellum, which then separates the tonsils from the biventral lobes, two structures that we're going to be talking about in a few minutes. We're moving on and now talking about the different lobes of the cerebellum. And we can divide it into three lobes: the anterior lobe, the posterior lobe, and the flocculonodular lobe. Bit of a tongue twister here. Now let's move on and start with this highlight here. This is showing then the anterior lobe of the cerebellum. And the anterior lobe of the cerebellum is the most superior part of the structure and is, as I mentioned previously, separated from the posterior lobe by the primary fissure, which you can also see here highlighted here on this image. Now, from a functional point of view, it is responsible for mediating unconscious proprioception and receives input mainly from the spinal cord. Next, we're going to be highlighting another lobe. Now, this one is the posterior lobe of the cerebellum. Now, this is the part of the cerebellum that is found below the primary fissure, and as you can see here on these two illustrations on the screen, it is the largest part of the cerebellar hemispheres. It plays an important role in fine motor coordination, specifically in the inhibition of involuntary movement via inhibitory neurotransmitters, especially GABA, G-A-B-A. The posterior lobe receives input mainly from the brainstem and the cerebral cortex. Next, we're going to highlight the other lobe that I mentioned or listed before. This is known as the flocculonodular lobe, which is also known as another tricky name, the vestibulocerebellum. This part of the cerebellum consists of a central part, and which is known as the nodule, and two lateral parts, which are known as the flocculi. Moving on, we're going to highlight these two structures here, which are known as the flocculus. Combined, they're known as the flocculi, which we talked about on the previous slide. There are two small lobes of the cerebellum located at the posterior border of the middle cerebellar peduncle. And from a functional point of view, the flocculus receives input from the inner ear's vestibular system and regulates then a balance. In addition, many floccular projections connect the motor nuclei involved in control of eye movement. Next structure we're going to be highlighting here is known as the nodule of the vermis, and the nodule of the vermis is located at the midline, as you can see here in our illustration, and it connects the two flocculi via the thin pedicles. The nodule is a median located structure, phylogenetically most primitive structure of the vermis of the cerebellum, and the two flocculi together with the nodule make up the flocculonodular lobe, which we talked about on previous slides. If we go back then to the flocculonodular lobe to talk about the function here, this structure plays a pivotal role in maintaining balance and is responsible for the vestibulo-ocular reflex. So any lesion in this specific part of the cerebellum impairs the person's ability to then control ocular movements during head tilting and posture while standing or even walking. Next structure we're going to be highlighting now is known, and we talked about before, this is the vermis. Now we're going to talk about the vermis in a little bit more detail. Now, the cerebellar vermis is a narrow, worm-shaped structure that is located between the two hemispheres of the cerebellum, which you can clearly see here on this image. Now, the cerebellar vermis receives information from the spinal cord about then senses of touch and proprioception. The cerebellar vermis also receives information from the body about hearing, vision, and also balance. And the various fissures in the surface of the vermis divided into 9 parts, or known also as the lobules of the vermis. Now, these lobules are often difficult to observe during your anatomy classes and may vary in size and shape. So now let's take a look at the lobes of the vermis, starting with the first lobule of the upper portion of the vermis, which is known as the lingula. Now, the lingula is a small tongue-shaped process, and as you can see in this illustration, it is the only part of the vermis that is not related to any lobule of the hemispheres. And another important thing to remember for the lingula is that it is attached to the superior medullary velum, which you can see here highlighted in green. Now, the superior medullary velum is the superior wall of the fourth ventricle, and you can see it here then highlighted in green. Next, we're going to be highlighting here is known as the central lobule, which is the second lobule of the upper portion of the vermis. Now, this one is a small square-shaped lobe located in the anterior cerebellar notch. It overlaps the lingula, from which it is separated by the precentral fissure, and it is related with the wing of the central lobule pertaining to the hemispheres. The next structure we're going to be highlighting is known as the culmen, and this is the third and largest lobule of the upper portion of the vermis on the superior-inferior axis. It is separated from the next lobule, the declive, by the primary fissure and is related with the quadrangular lobule, which you see here highlighted in green on this image. Next, we're going to be talking this one that I mentioned before, the declive. Now, this is the part of the vermis of the cerebellum just caudal to the primary fissure. The declive is related with the simple lobule of the cerebellar hemispheres, which you see here highlighted in green. Next, we're going to be highlighting this structure here, which is known as the folium. And the folium of the vermis is one of the smallest lobules of the vermis. It is separated from the tuber by the horizontal fissure and is related with the superior semilunar lobule, which you see here highlighted in green. The next structure I talked about on the previous slide, this is known as the tuber, which is the next lobule of the vermis that we're going to talk about, and it is just below or found just below the horizontal fissure. It is related with the inferior semilunar lobule, which you can see now here highlighted in green. Next, we're going to see here now this structure highlighted, which is known as the pyramid of the cerebellum. The pyramid is the seventh lobule of the vermis on the superior-inferior axis. It is separated from the tuber and the uvula by the prepyramidal fissure and the secondary fissure, respectively. Now, this lobule is related with the biventral lobule of the cerebellar hemispheres, which you see here highlighted in green. Next structure we're going to be highlighting here on this image, this is known as the uvula of the vermis. Now, the uvula is the second largest lobule of the vermis, following the culmen. It is separated from the nodule by the posterolateral fissure. Laterally, the uvula is related with the structure that you see here highlighted in green, which are the cerebellar tonsils, also called the amygdala cerebelli. Now, these are two rounded lobules on the undersurface of each cerebellar hemisphere. We're moving on and talking about this structure that you see now highlighted here. This is known as the nodule of the vermis. Now, this is the final lobule that we're going to be talking here on this tutorial, and it is part of the flocculonodular lobe. if you remember from previous slides when we talked about it. Now, the lobules of the vermis can be better remembered with the aid of the following mnemonic. Loving, caring children donate food to poor and fed needy. So L for lingula, C for central lobule, another C for culmen, D for declive, F for folium, T for tuber, P for pyramid, U for uvula, and N for nodule. And another important thing to remember is the relation of the lobules of the vermis with the lobules of the hemispheres. So in this slide, I will show you this relation. So in the left column, you see the lobules of the vermis, while in the right, you see the corresponding lobules of the cerebellar hemispheres. So first we have the lingula, which has no relation with the hemispheres. The central lobule, which is related to then the wing of the central lobe. The culmen, which is then related to the quadrangular lobule. The declive, which is then related to the simple lobule. The folium, which is related to the superior semilunar lobule. The tuber, which is related to the inferior semilunar lobule. The pyramid, which is then related to the biventral lobule. The uvula, which is related to the cerebellar tonsils. And finally, the nodule, which is then related to the flocculus. And before we end this tutorial, let's take a look at two other structures that we see near the cerebellum. And these are, here on the left side, the inferior medullary velum, and on the image on the right side, you see then the superior medullary velum. These structures form the roof of the fourth ventricle. So in this tutorial, we cover the connections and the external surface of the cerebellum. In another tutorial, we will discuss the white matter and the nuclei of the cerebellum. So stay tuned for other tutorials here at CanHub. Now that you just completed this video tutorial, that is time for you to continue your learning experience by testing and also applying your knowledge. There are 3 ways you can do so here at CanHub. The first one is by clicking on our Start Training button. The second one is by browsing through our related articles library. And the third one is by checking out our atlas. Now, good luck everyone, and I will see you next time.